Hey everybody, what's going on? It's Joel Irway with dailyfeexamprep.com, and in today's lesson we are going to be talking about algebra of complex numbers, and this is the introduction, or part one of this lesson series. So let's get started. So the goal of this lesson for today is to give you an introduction and general overview for the algebra of complex numbers. So the overview of the lesson that we're going to be talking about today is, first we'll define what a complex number, a real component, and imaginary component, and what J is. We're going to discuss what are polar and rectangular forms, and we'll discuss why and where they are used. We'll also introduce the rectangular and polar form equations. Okay, so in the definition that we're going to talk about, complex numbers are numbers that can be expressed in the form a plus jb, where j is the imaginary unit, a and b are real numbers. If z represents a complex number, then it must be expressed in the form a plus jb for some real numbers a and b. Or z is equal to a plus jb, where j is the imaginary unit and a and b are real numbers. Okay, so the real number a of a plus jb is called the real part of the complex number z, and the real number b of a plus jb is called the imaginary part of the complex number z. So the imaginary unit j is defined as the number such that j squared is equal to -1. Okay, so that's very important. So we'll talk about that in future videos, but if you ever forget, just come back here and review this video as an introduction. So the form of a complex number z in which it is expressed as z is equal to a plus jb is called rectangular form. Okay, so in rectangular form, the complex number z can be graphically represented in Cartesian coordinates called a complex plane, where real part a is along the x-axis called the real axis, and imaginary part b is along the y-axis called the imaginary axis. So the origin of the Cartesian coordinate is a point where both real and imaginary parts of a complex number is 0 and is represented by 0. In the polar form, a complex number z can also be represented as r angle theta, okay, where theta is measured from the positive real axis and r, called the modulus, is the distance of origin 0 along the direction theta, called the argument or phase. So the usage of rectangular form and polar form. Addition and subtraction of two complex numbers are more easily calculated in rectangular form. Sometimes a complex number is used to represent a physics quantity, or for example, the electrical impedance Z is expressed in rectangular form as Z is equal to R plus JX, where the real part R is resistance and the imaginary part X is the reactance. Okay, so in polar form, the algebraic operations of multiplication, division, and taking roots can be performed more easily than in rectangular form. So an introduction of rectangular and polar form equation, well, the formulas can be found on page 19 of the NCEES Supplied Reference Handbook, version 9.2. And a complex number in rectangular form, z is equal to a plus jb, can be converted into polar form, r angle theta, by the formula r is equal to the square root of a squared plus b squared, and theta is equal to the arctangent, or the tangent inverse, of b divided by a. Now the polar form z is equal to r angle theta can be converted into rectangular form z is equal to a plus jb by following the equation a is equal to r cosine theta and b is equal to r sine theta, or r angle theta equals r cosine theta plus j r sine theta, which is equal to r cosine theta plus j sine theta. All right, so what's up next for you? Well, you can either please check out the sample problems for additional practice if you need it. If you have any further questions, please let me know in the comments below or in the lesson plans. And if this helped you at all, please do us all a favor and like and share these if they helped you out so we can help grow this engineering community. So hopefully this was helpful for you. Stay tuned for the next lesson, and thank you so much for watching.